All right, guys, this is the Unit 7.1 notes. We are going to be in this packet on page 1. Today's learning target is, I can simplify radicals. Clearly, I need a new pen. I can simplify radicals, okay? This is going to be the foundation of what we do the next couple lessons. What is a radical? Okay, a radical is also known as a square root or just a root. Okay, you probably see it like this. Okay, we are going to simplify those, which basically makes them smaller, easier to work with. We're not changing them, we're just simplifying them. Okay, and so we're just going to kind of hop on in. If you have been to class, or if you haven't, I would ask your teacher for one of these cheat sheets that you can use in your playbook. I'm going to be referencing this throughout the process. First step when you're simplifying any radical is you are going to first ask yourself, okay, the square root of 36. Is this a perfect square? Well, what do we mean by perfect square? Perfect squares are numbers where if you multiply two of the same numbers together, you get that number. So for instance, the square root of 36 would be 6, right? Because 6 times 6 is 36. So this one's pretty simple. What is the square root of 36? Well, it's literally just 6. Super simple. But now, check out number 2, okay? The square root of 8. If we were to put the square root of 8 in the calculator, what happens? Oh no, it's a decimal. So in math, we're not going to call it 2.82843. We're going to try to simplify that radical. Here's how we do that. We need to find the factors of the number under the radical. Okay, so for instance, in our cheat sheet, we talked about finding the factors of 50. So numbers that multiply together to give me 50. In this example, we used 2 and 25. We could have used 5 and 10. That's about it. Probably the only options. So what are two numbers that multiply together to give me 8? Okay, we're not going to use 1 times 8. That's not helpful. But we could do 2 times 4. Hopefully that comes to mind. 2 times 4. If it doesn't come to mind, you can always get a calculator out and start dividing 8 by stuff. So 8 divided by 2 would be 4. So that means 2 times 4 is 8. Okay? So we've broken down 8, and we're just going to keep breaking down this number until all of our numbers on the tree are prime. Okay? What is a prime number? A prime number is anything that can only be divided by itself and 1. So, for instance, 2 is what we call a prime number because 2 can be divided by 2 and 1. And that's it. What about 4? 4 can be divided by 4 and 1, but also 2. So you can break down 4 even farther into 2 and 2. Okay? Now, anytime you break down a number, I want you to cross it out. So we are left with 3 2's. Okay? Here's what it says to do on our cheat sheet. In the box stays in the box. Okay? Oh, sorry. I got a little bit ahead of myself. When we're at this point, we are looking for pairs of numbers. Okay? We're only looking at 2, 2, and 2. Okay? Are there any numbers that can pair together? Well, we could pair this 2 and this 2. Anytime I pair, I'm going to circle the numbers. We have a pair of 2's. Then the Lone Ranger, 2, is just chilling. I'm going to box them. Pairs get circled. Lone Rangers get boxed. Okay? So in this situation, this is how I'm going to write my answer. Okay? If it's in a box, if a number is in a box, it's going to stay in the box. So if this is my square root, anything that's been boxed is going to stay under the square root. All right? But pairs get to escape the square root. So I'm going to write not 2 times 2, but just 2, representing both numbers. Okay? So a pair gets moved to the outside. So for instance, these were paired up, so they go right here. And this one was boxed, so it stays in the box. This is a little box. It stays in the box. Okay? And if you're like, oh, Mr. Colston, I don't know, I'm kind of confused, hang in there. Give it a couple rounds. You'll get it. Okay, let's look at number 3. Very similar idea. If I were you, I would pause the video and try to do number 3 on your own, see how far you get. So number 3, I'm going to, let me zoom in a little bit. Number 3. Okay, I'm going to think about pairs or factors of 50. Okay, what comes to mind for me is 5 and 10. 5 and 10. Could I have done 25 and 2? Absolutely. 5 and 10. Okay. 5. Can that break down any more? No. 5's prime. 10? That could break down into 5 and 2. Can 5 break down anymore? No. Can 2 break down anymore? No. So we're done. Okay. 5's are a pair. All right. 2 is boxed. So if we stay consistent with this strategy, okay, I highlighted the circles yellow and the box blue. So anything that was blue goes under the box. Anything that was paired up stays outside the box. Okay. So hopefully you're getting the hang of it. It's really not too bad once you're cooking with it. It's not too bad. Let me turn off my, it's a little bit too bright. All right, 5 square root of 2 would be my answer here. Okay, so I went from the square root of 50 to this 5 square root of 2. Now, how could we check our work? This, Mr. Colson, this just seems like a lot of random stuff. How about we check it? So if we were to put square root of 50, which was our original problem, in the calculator, that's the decimal we would get. Let's put our answer in the calculator as well. 5 square root of 2. Same answer. If these decimals would be different, if our original problem and our answer are different decimals, you did something wrong. Got it? Number 4, same idea. This is still the same process. Okay. If you're still struggling with how to find factors, let's try that. 18 divided by 2 would give me 9. We could roll with that. 18 divided by 3 would give me 6. So we could do 3 times 6 or 2 times 9, either one. I'm going to do 2 times 9, but either way would work. All right. So in this situation, we have 2 and 9. 2 is a prime number. 9 can continue to get broken down. 3's are both prime, so I'm done. Those can get circled. This can get boxed. Remember, if I circle them, it escapes the jail of the radical. If it's boxed, it stays under the radical. So 3 root 2 would be our answer for number 4. Okay. So if you ever get confused on those types, you can always use this answer sheet, this cheat sheet. Okay. Let's keep going just a little bit more. You don't have to listen to all of these. If you're already clicking, you can move on and skip maybe to number 7. But I'm going to show you how to do number 5 and 6 real quick. 175, you might not know anything that goes into 175. It's an even number, so we know we can't use 2. Okay, let's try 3. Still can't work. What about 4? No, that wouldn't work. 5, 35. How about we try that? 5 and 35. Okay. Is 5 prime? Yep, so we're done. 35. That can break down into 5 and 7. Those are both prime. Got a pair, so it's going to go outside. We got a box, so it's going to go inside. 5 root 7. Okay. What about number 6? I could do 8 and 9, 72. 8 times 9 is 72. Multiply these. This would give me 4 and 2. 2 is prime, so that one's done. 4 is not prime, though, so I could do 2 and 2. 9, is that prime? No. I could do 3 and 3. Interesting. Okay, so I think we're done, right? 9 goes away. We have a pair of 2's right here. We have a pair of 3's right here. And then 2 is by itself. Okay, so let's walk through slowly again how we do this, because now we got a couple pairs and we're like, oh my gosh. So remember, if it is paired up, it goes outside the radical. So if here's our radical, 2 is outside the radical, 3 is outside the radical. And you're like, Mr. Colson, there's 2 pairs, what do I do? All you're going to do is multiply them together. No worries, we'll address it later. Okay, so 2 and 3 end up outside the radical. What ends up inside the radical? The boxed number, which is 2. Okay, we're not done. Okay, this is still kind of messy. We need to do 2 times 3, which would give us 6 root 2. Okay, looks good. What about number 7? So number 7, we're going to start using some different things. So number 7, we got a couple different options according to our cheat sheet here. I'm going to teach option 1 first. Okay, in this problem, we are multiplying 2 radicals together. Okay, so in this problem, we can either, option 1 would basically have us break down 15 and then break down 10. Break down 15 and then break down 10. So let's try that. 15, what are the factors of 15? 5 and 3. Those are both prime, so we're done there. 10, 5 and 2. Also both prime, so I think we're done. Do we have any pairs? 5 is a pair with 5. Okay. 3 is solo, 2 is solo. Okay. So in this situation, if I'm paired up, remember it goes outside the radical. If it's inside the radical, the box ones are going to go inside the radical, excuse me. So we're going to have 3 inside the radical, and then we also have 2. What do we do when we have 2 of them? We're going to multiply them together. No big deal. Okay. So are we done here? No. Look here at this example. Remember, kind of like in number 6, we weren't done. We just have to clean it up a little bit. So we need to clean up what's inside the radical this time. 5 root 6 is going to be our final answer here. Okay. So that is one option. You can break each of the radicals down individually. You can also multiply them together first. So the rule is if you see numbers that are outside the radical, you can multiply them together. If you see numbers that are inside the radical, you can multiply those together. But you can't mix and match. So for instance, 4 underneath the radical, 8 underneath the radical. So this can become square root of 32 because 4 times 8 is 32. Okay, but we're not done. We then have to break that down all together. So 32, well, what could it break down to? 4 and 8, obviously, right? Didn't we just do that? Okay, 4 would break down into 2 and 2. Get rid of that 4. 8 would break down into 4 and 2. Get rid of that 8. 2's good. 4 could break down into 2 and 2. Oh my goodness. So we have a bunch of 2's. This guy, this guy, this guy, this guy. 2 times 2 would be on outside the radical. And then this guy's boxed. Square root of 2. So 4 square root of 2. Okay. I know I'm going kind of fast, but I've gone through a couple examples now, so I think y'all are probably feeling pretty good. Let's take a look at number 9. Number 9. So here we're still multiplying by the, we're multiplying different radicals, okay? But if you take a look here, now we have this element of things are on the outside of the radical. So like I said, if you have a number that is outside the radical, you can multiply it by another number that's outside the radical. Same with inside and inside, okay? You can't mix and match. So in this problem, we have 3. 3 could come down. There's nothing to multiply 3 by, though, right? Because there's nothing right here outside the radical. There's nothing there. So now we start inside the radical. 8 times 6. 8 times 6 would give me 48. So 3 root 48. Okay, let's stop and make sure we know how we did that. Okay, we did the ones inside the radical. We multiplied those together because they're both inside the radical. 8 times 6 is 48. So now we have this situation. We need to simplify the square root of 48 before we move on. So just so we know that 3 isn't forgotten about, I'm going to highlight 3 real quick just to make sure we don't forget about 3. Let's just focus on 48 for now, but 3 we'll come back to. So 48 could be broken down into 8 and 6. 8 could be broken down into 4 and 2. 6 could be broken down to 3 and 2. 4 could be broken down into 2 and 2. Okay, I know I'm kind of running out of room there. Okay, so we got a pair of 2's right here. Got a pair of 2's right here. And then we got a box 3. Okay, so with all of that, we still have 3 out in front. We still have 3 out in front. But now, instead of the square root of 48, we're going to have, we got a 2 out in front, we got another 2 out in front, and then we got the square root of 3. Okay, so now we have something we can simplify. 3 times 2 is 6, times 2 is 12. 12 square root of 3. Okay. Very similar situation here. There is kind of a shortcut here, though. So, if you take a look, okay, negative 2 times, what is the square root of 16? Can't we rewrite that as something? Let's look. The square root of 16 is 4, guys. It's a perfect square. So instead of square root of 16, let's just write 4. Times, what's the square root of 9? It's 3, guys. Let's just write 3. Oh my gosh, we got rid of all of our radicals all at once. So negative 2 times 4 is negative 8, times 3, negative 24. Okay, that one was super simple. So always be on the lookout. There might be some perfect squares hidden in there. Okay, what about 11? What about 11? So let me rewrite this just so it's very clear. Negative square root of 441. Okay, 441, that's a big number. I don't know what goes into 441. Let's just start trying things. It's an odd number, so we can't do 2. How about 3? Boom. Works. By the way, we always want to make sure we have this negative out in front. Okay, so we don't want to forget that. Let's focus on square root of 441. We have 3 and 147. 3 is prime, so we're done there, but 147, man. What about 3 again? Ah, cool. 3 and 49. 3 is good. 49, isn't that 7 and 7? Okay, so now at this point we have a pair of 3's and a pair of 7's. So, as a reminder, we still have this negative out in front. 3 will get broken free. It's outside the radical. 7 will also get broken free. There's no boxed things. So this is going to just end up being negative 21. There's nothing under the radical. Cool. How could you check this again? Let's remind ourselves. Let's put our original question in the calculator. Negative square root of 441. Negative 21. Boom. It's the same thing. Okay, you can always check your work. Number 12. Okay, so this one's kind of weird. Another rule with radicals is that if you have the square root of something entirely, you can also write this as the square root of 169 over the square root of 225. I don't know, just a fun fact. Kind of makes it look a little bit easier. These are some big numbers, but if you're good with math, you might already know that these are both perfect squares. So let's take a look. The square root of 169 is actually 13. So this would just simplify to 13 on top. The square root of 225 is 15. So that would simplify to 15 on bottom. Boom. Okay, 13 over 15. Hopefully y'all are still feeling good. We're going to enter kind of the last phase of this. We're going to basically rationalize the denominator is what this is called. So on your cheat sheet, if you're looking at that, is the bottom right. Okay, there's a very simple strategy. So in math world, there's just this rule, it's silly. You can't have a square root on the bottom of a fraction in the denominator place. So when that happens, we have to do what's called rationalizing the denominator. And so the square root of 2 has to be changed. Here's how we do it. Very simple. Look at your cheat sheet. There's 2 steps. Multiply the top. Okay, here's the top. I see it, 3. Multiply the top by the radical from the bottom. Oh, okay. So this is now going to be 3 times the square root of 2. Huh. Okay, good to know. What's the next step? Free the radical in the denominator. So that means I don't have a radical anymore on the bottom. Interesting. So could I just kind of squiggle it out? Boop, 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 boop. Huh, that's my answer. 3 square root of 2, that's being multiplied together, divided by 2. That's our answer. Now, a couple questions that you might have. Mr. Colston, why did you not do 3 times 2 and get 6 somehow? Why didn't that happen? Well, if you notice, 3 is a number that's outside the radical. 2 is a number that's inside the radical. Can you multiply those together? No, you cannot. That was a rule we learned earlier. So they're just going to stick together. Kind of like when you multiply 3 and x, they just stick together. Kind of the same idea. They're just going to chill. Other question is, why do I not do anything else? Well, 3 over 2, that fraction cannot be reduced anymore. So you're just done. Easy peasy. Okay, let's try that again. Number 14. Same 2 steps. We have a radical on bottom, so we got to do this. We got to rationalize the denominator. I'm going to multiply the top by whatever's on the bottom, root 3. And then I'm going to get rid of that square root. So I have 6 square root of 3 divided by 3. And I'm done, right? I'm not done. There's one tiny little thing. If you'll notice here, I had 3 over 2 as my fraction. That can't be reduced. Let me just prove that to you real quick. 3 divided by 2 can't be reduced. But what about 6 divided by 3? That can be simplified to 2. So in other words, this would become a 2. This would become a 1, which is kind of like nothing. 2 root 3 would be your answer here. Okay? Kind of interesting. All right, what about 15? Same exact steps. I'm going to multiply the top by the radical from the bottom. So I'm going to multiply 5 times square root of 2. Going to get rid of the radical. So I'm going to be left with 5 root 2 over 2. Boom. All right, you kind of get the idea now. 16 is kind of crazy, so let's talk about 16. 16, same exact thing. I'm going to multiply whatever's on top, the whole thing, 6 square root of 2 times the square root of 3. Going to get rid of this guy. So let's rewrite it. 6 square root of 2 times square root of 3 all over 3. So there are 2 things wrong with this problem at this point. Not anything I've done wrong, but 2 things I need to fix before I circle my answer. Okay? One thing is on the top in the numerator, there's some cleaning up to do. 6 is outside my radical. There's nothing else outside my radical. Can't do anything. But 2 and 3 are inside the radical, so I can multiply those together. That would create a situation where it is 6 square root of 6. So 2 and 3 are multiplied together to give me 6. Got it? 3 is still on bottom. That's cool. But I don't like that. I'm going to do the same thing I did up here. See that? 6 divided by 3. 6 divided by 3. What happened there? This became a 2. This became a 1. So I'm left with 2 root 6. Okay? All right, guys. Good job. Come to tutoring if you ever need some more help. Hope you guys have a great day. You're going to work on the practice, which is pages 3 through 6. Have a good one.